Welcome, folks, to another episode of Legacy Code Hero. Today, we're gonna have a lot of fun. We're gonna try to debug the XServer code as it tries to load the driver I'm working on. And we are gonna start with the point where when the user plugs in the device. So that's what I'm gonna do right now. The gamepad is not connected to my Linux machine right now. What you're seeing is the screen on the Windows machine I'm using. I have to use SSH to run the debugging session like I mentioned before. If you don't do that, you're gonna be locked out. You won't be able to control your computer. So let's start right away and let's see what can we learn through the debugging process. Okay, so it's connected, and as you can see, GDB has stopped exactly at device added. As you know, this function is in config udep from the XServer. Essentially, what it means is that it has found a device that has been just connected, and this is my gamepad. So let's start by seeing what happens with the arguments, and we can try to print that out. udep device to see what do we get. It's an incomplete type. That means that we won't be able to pick into it from here. That's fine. So what we can do now is start finding where should we put the first breakpoint, and I think we should do that at line 110 after the system path and the path of the device has been found. So let's do that. Let's set up that breakpoint there. And let's continue, execute the code, and let's try to print the path. There's nothing there, and let's do that again. Okay, so it has to run one more time. I'm going to continue. The code is calling the same function, and I'm going to hit continue again. And now we can see that we have dev input.js0 device. In Linux, these kind of devices are for joysticks. However, when you try to read data from these devices, you will be using the older or the legacy API. I don't want to do that. I want to use a newer one. So this is why my driver has to modify this to to dev input event. So we're gonna look into that. So let's look at the sys path, and there we go. This is generated by udeb. This very long string. We don't need to. If we wanted to know how this is done, we will have to look at udeb code, and I think that's a lot of work. Let's just be happy that we can see the value that I returned. And now let's start seeing where else should we put another breakpoint so that we can look into that. I'm gonna stop here at this position, the first input options. Like I mentioned before, this is a linked list of key value pairs, and the first one is to set the source to server udep, and we're gonna try to look into that. So let's stop at line 146, and there we go. I think we can print input options. This should be a pointer, and we can see that we have list next. There are no more 8 items because this is the first item in the linked list, so this makes sense. The option value and the option name, we got it, source and server udep. This gives us an idea how these things are stored in memory, and there are other fields, and that's it. So we can continue looking into here. Here it should set the parent product path and things like that. We're not gonna stop there. We're gonna stop more ahead. We may not want to look at all that, so we're gonna stop at this line where it populates other options for our device. So let's do that. 195. Okay, there we go. Oh well, the thing is that by stopping here, what has happened is probably that it has added more items to this list, but if we wanted to look at all of them, we will have we should have stop at each point and see what's in there. So what we are going to see is probably the last one. No, actually, let me see. Probably we're going to see the first one, because these things usually, right, what it returns is the head of the list, which is the item that we already saw, but at least we can look at next. It's not null, it's not zero, so there's something there, so we are sure that these options are in there. So let's continue. Later on we can look into all these options from the driver code anyway, so it's not necessary maybe to look at it right now. So this is a relatively big function, so we're probably gonna stop right when it calls new input device request. So I'm going to put a breakpoint there, so that you see that it got called, and we can look at the options, the attributes. At least we can look at that from here. And there we have the product name of my gamepad is this name. It's a Wii controller, I think, or a Switch controller. Here is the device name and the USB ID. That's all this data was set up by UDEV. And that's it. So what we're gonna do is that we have seen these before. So what we're gonna do is stop where at the point where it calls our driver. So I hit continue, and I already set up these breakpoints before I started the recording. So this is why you didn't see me setting up the breakpoint. So it's not magic. I had to do that before. So you probably don't care too much about what I'm doing here. I'm just allocating some memory, and it's storing some private data for the module so that I can use that later on, and then it returns the teardown data. This is what the module expects. If you don't return something, it's going to reject the driver. This is the reason why you have to return something. And in here, I'm returning the private data, and that's what it should do. If there's no private data, you just return a pointer to the module, which is one of the arguments here. Exactly. So if you look at the other driver, you're going to see that it returns not teardown data, but it returns the module itself. And you have seen this function already. It just adds the input driver to the list of input drivers that the XServer has. There's nothing too interesting there to look at. So we can continue. And now for the first time, it's going to call the gamepad core pre-initialization. This happens way before the device is enabled, let's say. We're just doing some pre-initialization code, running some pre-initialization code. Like I mentioned before, this is called twice. Once when you are doing it for the driver joystick, after you're doing the hot plugin or the keyboard for your gamepad. And if this is not the case, which is gonna happen the first time, it's gonna do this. So here, what we can do, actually, I think you will be interested in this part. So I'm gonna keep going down. Yes, I'm doing a lot of checks because I'm learning from writing the driver myself, and I like to use checks to make sure things are okay when I'm running the code. So I'm going to get the device name here. This is a function that I wrote. So what it does is, we're not gonna look in the code, but what it does is essentially I give in the product name, and it's gonna look at all the devices under dev input for a device that matches this, and that is actually a gamepad. It's just an additional check to make sure that UDEV didn't make a mistake. Of course it didn't, but it doesn't matter. I can check anyways. This is just a habit of trying to write robust code, let's say. So if the return code is 0, it means that everything was okay, and we can check. Now we can check the device name. So what we're gonna do is get the device name from the private data, and we're gonna print that. This is dev input event 8, right? So in Linux, when you plug in a gamepad, there's gonna be dev input.js some number and some dev input event some number, in this case 8. uh, this is done just because the Linux kernel wants to be backwards compatible. That's it. That's the reason why you get two special devices for the same controller. So what I do here is that I replace the device path in the input in gamepad options. I'm just using the actual dev input event instead of JS0. That's all this code is doing, and I'm just gonna continue because you might not be so interested in looking at all of that. Okay, so these are all the options. Maybe we want to look at some of the options here. So let's stop at 601 so that you get an idea, and let's put a breakpoint afterwards, like 607. Okay, so we are there, and let's print the options before we get a new one. And there it is, the first option you saw earlier, source server UDEP. And let's look at the next one. Okay, yeah, this is the name of the device. This is a product name. And let's continue. And here it is. This is the device. This would be the device path. Again, what we found earlier, it has been modified. Okay, let's do this one more time. Maybe there's some other data you may want. Okay, this is device major and device minor. I didn't talk about this, but in Linux, you use these two numbers to reconstruct the device ID. That's how essentially how it works. Let me continue here. This is gonna be device minor, so I'm not gonna show it to you. And this config info, this is probably the last one. Modifying this is something that we shouldn't do, because eventually the XServer is gonna use this string to remove the device. So if we modify this, we are gonna do something that the XServer doesn't expect. And honestly, we don't want to modify this, so this is why I'm not touching that. That stays the same. So this is one reason why you should read the source code and try to think things through before making a big decision like that. And we're still testing. It's fine to test, crash the server if you must, that's fine. That's how you learn. And this is why I'm doing this series, to learn and to share how you can also do that by experimenting, even if it's a huge code base. It doesn't matter. You have the time, you can do it. So this is the attributes. We have to update the device. It's still using the previous one, and this is what this code does. This memory here, attributes device, is allocated on the heap, so we have to free it. I nullified just because I like to do that, and then it just duplicates whatever update device name I had. Okay, and I have to use a string duplication, because when this is destroyed, this data is destroyed by the XServer, eventually it will try to free it. So it's necessary to call string duplication here. Also, something that I figured out by reading the source code. Okay, so everything looks okay. So it's gonna do the GamepadKeyboardHotplug. So let's hit continue, and it's there inside a function. This one, I believe, is not. It's pretty much follows what is done in the original code, with some minor simplifications. There was some data duplication that's really not needed. It's done twice. Don't know why they didn't just call these functions. So it's a little bit more, it's tiny. This one is like a simpler version of it. The important thing here is to update the source on the driver joystick for the reasons you have seen before. So let's create a breakpoint at 177. Okay, it calls NewInputDeviceRequest, but this time it's doing that for the keyboard. So let's continue. And now we can verify that it's showing us information for the keyword. So if you remember the previous function, maybe I should have mentioned that we modified the name so that when you're dealing with the keyword, this is the data structure that stores all the information for this device. When it has keys, it means to us that this is a keyword, essentially. Everything else is the same. So we didn't modify anything else other than this string right here, this option. So this is gonna call GamepadKeyboardPreInit. So if we hit continue, it should stop there unless I forgot to put the yeah, I think I forgot to do that. Okay, info breakpoint, let me see. GamepadDriverSetup, the hot plugin. Oh yeah, keyboard pre-initialization. It should call it. So let's do that. Yeah, there it is. And we can check info arguments, and there we have. Let's print the info keyword so that we can verify things are okay. At least the name, it's what we expect. It's keys, okay. This is the data structure for the keyword, and we can continue. This is not complete. Okay, so even though it's gonna say everything's okay, it's not. It's different. It's actually doesn't practically do anything in the actual driver for the joystick. It does a couple things that are specific for keyboard devices. I haven't done that yet. I'm just experimenting here. So from this point on, the server is going to complain that I didn't provide a device control. And this would mean that it will reject the driver. If I did not handle memory freeing or the destructing of data, the server is going to crash. So, and this is very important to test it so that if you see that you get a 6 segmentation fault or something like that, that means we can delete all of this. That means that the server crashed. But by deleting all breakpoints and hitting continue and seeing that the server is running normally, that means that there was no crash. The driver is incomplete, but it was safely rejected by the XServer, and that's okay. I'm still in development. As you see, I'm testing things out and also learning how the server handles errors if I don't provide something that I should, like that procedure right there. It simply rejects the driver. If I do the right thing with memory, I'm not going to crash the server. And I have crashed the server a couple of times. It's fun. But from the SSH, you can remove the driver from the file system. Let me see if I think I have another, just in case if that happens to you. All right, but this one is on the Windows drive. This is not going to show you the path, but I can detach from here. Let's do that. If this ever happened to you, so we can go to user list modules. If something goes wrong, here's my gamepad driver. We can remove that, and that's it. If your computer starts like, well, if all the screen goes black, then you know that you crashed the server and it cannot. System B is trying to start again the server, but the server is going to crash again, and then system D is going to try again, and it's a never-ending cycle. So you have to remove the driver. Probably sometimes unplugging the device may save you, depending, but the safest bet is to remove the driver so that when it tries to start again, it's not gonna load it, and you will be safe. Okay, so if this ever happens to you, so we didn't look at the interesting things of debugging with GDB, like looking at the assembly instructions and things like that, because we were mostly looking at my code, which I didn't compile with optimizations on purpose, just because I wanted the code to map as closely as possible, meaning that it won't do inlining, it won't move things around, it's gonna be predictable. So it's making it easy for me to look at the code. But actually navigating through the XServer code, it's hard because it's optimized. And so the assembly instructions, there are gonna be probably many because of the inlining and other optimizations that it's gonna do. We didn't do that today because I just wanted to focus on the and to give you an idea of how to debug a driver once you actually get it to call by the X server. The hard thing is finding out how does that happen and making sure that it loads the driver. Okay, so guys, I hope that you enjoyed this session today. I'm looking forward to know from you and looking forward to the next episode. Have fun and stay tuned. Take care.